Welcome to Physics 100. Today I'm going to talk about physics and what is the basis of physics. Actually, more broadly, what is the basis of science? So I'm going to talk about the scientific method and the basis of science. As I said, this is Physics 100 and I'm glad to meet you. I just want to show what I look like here. Science, biology, chemistry, geology, and physics are some examples of science. Physics might be defined as the basic nature of matter and the interaction that governs its behavior. What is science? A science follows the scientific method. The scientific method is a continuing process that can identify a false understanding of nature. Science cannot prove something is true, just to reduce the possibility that something is false. Science takes a long time. You need patience to go into science because of this. So here's the scientific method, a diagram trying to explain it. You start out with some test or observation, and then you look for a pattern. Let's say you see the sun rise in the east and set in the west, and then you see it again the next day and the next day. You say, the sun's going to rise in the east the next day, tomorrow. And then here's the part that we become a science. You see a pattern and you develop a hypothesis, a guess as to the mechanism of what you are seeing, how that occurs. And so, for instance, you might guess that the sun is born out of some mountains to the east and might extinguish to some lake in the west. Then you would go and try to prove or disprove such a hypothesis. So a hypothesis is just a guess. Most of the time it's wrong. But that's the beauty of this method, is you go and use this guess to help you understand. And so, for instance, with the idea of the sun being born from some mountains to the east, you might go and spend the day, hike to the mountains, and look to see if the sun is bubbling up from those mountains. When it does not, then you go and abandon that hypothesis and develop a new one based on your past understanding. So the patterns that you saw before, they're still valid, they still tell you something, but this new information tells you more, and you develop a new hypothesis that fits into the new data. Once again, most of the time that's wrong. But through many different tests and observations and other people working in the field, you can develop something known as a theory. A theory is something that has survived many different ways of testing and many different observations. And each time there's a test or observation, this thing seems to be more and more valid. You find you're more certain that this thing is correct. You're never 100% correct, but you're more and more certain. And at that point, you elevate this to a theory. A theory is still part of the scientific method, meaning that you could have some test or observation that could knock down a theory, and you have to start the process over again. Once again, you have a great knowledge base when you get to that theory. But if something's elevated to the level of a theory, if you have a test or observation that seems to go against that theory, the first inclination is to see if that test or observation is repeatable. Is that really correct? If it is, yes, you can knock down, and this happens, knock down a theory and keep on going along the scientific method. This is a continuous process. It never really stops, but as we go through many cycles, we learn more. Rene Descartes and Galileo Galilei first wrote about the scientific method, but it's really been around a lot longer, centuries, millennia, before they were. Matter of fact, might have been around, probably it was around before there were humans. The scientific method is really part of everyday life. We just don't realize it. You hear a noise or you see something and you think it might be, and then you investigate. So, for instance, you're asleep and you hear a noise that wakes you up and you think, well, you could just go right back to sleep. But you think it might be something in the closet. And so you wake up, you go into the closet, turn on the light, and maybe it is something in the closet. Maybe it's not. And you go, well, if it's not the thing in the closet, maybe it's in this room, maybe it's this, maybe it's that. You develop hypotheses, and you go and test them through observation or tests. See, is this thing loose? Is this thing rattling? And perhaps you find it that night. Perhaps you don't. And maybe the next night you hear a noise again that wakes you up. And you go, well, I know it's not these things. So maybe it's, and that's really part of the scientific method. And so this is part of our lives. It's not really just done by people in lab coats and faraway places. It's really part of our lives. But we have the infrastructure of science that takes this thing that's part of our lives, and you can see how an animal does the same thing. They hear something, they smell something, they try and investigate what that is. And so, as I said, this has been around for a very long time. So what have you done lately that follows the scientific method? Have you done something like that? You heard a noise, you saw something, you say, wait a minute, this looks like well, that can't be. And then you go and investigate, and you say, oh no, I thought it was this. But really I find out that now I look at it, now I touch it, now I found it really isn't that. It was something else. I had that seemed unusual. I developed a hypothesis. I tested that out. You might have done that today without even hardly thinking about it. As I said, it's part of our lives. So, in summary, what is physics? Well, physics is a science. It investigates matter and how matter interacts with itself and the laws that govern its behavior, why it travels in certain patterns, what causes it to move and interact with other matter, the basis of our universe. Why is it a science? Well, because to understand this, they use the scientific method to investigate these hypotheses that they've had about physics, and these have developed into theories and into our understanding, our current understanding of physics. And like every science, it's never done. There's always more things to learn. The scientific method is something that is always ongoing. And hopefully it's something you will find interesting. Well, thank you.